I see we have members that are still joining into the session, but why don't we go ahead and get started to accommodate all of your busy schedules. So you all have joined an ongoing series of member webinars that the Cognitive Computing Consortium will be holding monthly over the course of this year. We've titled the series Leaders in Cognitive because we will be giving you the opportunity to listen to some of the most thoughtful and active executives and technologists practicing in the field today. We also, of course, encourage you to interact with us and the guest speakers as an integral part of this webinar format. We'll be kicking off the program with an introduction of Jeff and his work from Hadley Reynolds, who is co-founder of the consortium. We'll then have the opportunity to hear Jeff share his perspectives on the state of the arms race between Google and Microsoft in their respective bids to win the hearts and minds of cognitive developers everywhere. We expect that conversation to run approximately 20 to 25 minutes, and then we'll open up the program to your questions. For the attendees, as you can see, all of your microphones are on mute for the first portion of the program. If you'd like to ask a question, you can write in the chat window at the bottom of your control panel or use the raise your hand function in the top left area of your control panel, and I will unmute your line to allow you to speak your comments. I'll take questions in the order that they appear at the end of the program. So at this point, I'm going to turn the session over to Hadley Reynolds, who will get us started with the conversation.
Thank you, Hannah, and thanks to all of you on the line for taking the time to join us today. We also thank Jeff for taking time out of his busy schedule to speak with us. When we launched the consortium a little over a year ago, arranging opportunities for members to connect with the best thinking and the most interesting people in the field was perhaps our highest priority. Today, we're very pleased to be continuing our Leaders in Cognitive series of webinars with our guest, Jeff Fried. Jeff has been involved with consortium activities since the beginning. He was a core contributor to the team of 20-some people that developed the consortium's definition of cognitive computing some 3 years ago now. For the last 6 years, Jeff has been the CTO of BA Insight, a Boston-based software company specializing in products that accelerate the development of search-based applications. In their C-suite, Jeff says helpfully, CTO stands for Chief Troublemaking Officer. Jeff also tells us that he is, quote, a long-standing search and text analytics nerd dating back to a semantic search startup called Lingo Motors in the late 90s. He's probably best known more recently for his work with SharePoint, due in part to having worked at Fast Search and Transfer and subsequently at Microsoft, where he was responsible for integrating the FAST technology into SharePoint. In his spare time at Microsoft, he managed to co-author 3 books on SharePoint search and SharePoint development. As most of you are no doubt aware, search is an area that has already been deeply influenced by the rise of interest in machine learning and other cognitive technologies. In fact, cognitive search has become a new marketing meme for the industry. So it's not surprising that search technology companies are closely following developments in the open technology platforms around artificial intelligence that are being brought to the market today by the technology giants, Google, Amazon, Microsoft, Facebook, IBM, Baidu, and even Apple, which has just now joined the party with what they are calling Core ML. As CTO of the search business, Jeff has had the opportunity to look carefully at these developments and experiment with some of the new facilities at close range. So today he'll be sharing with us some perspectives on the players in this emerging space and their growing portfolios. He'll also be offering some first-hand stories from the field about what it's like to use these products in real-world projects. I'm very much looking forward to learning what he has to say, and I hope you will find this kind of hands-on, practical discussion helpful in your work and in your thinking. I'm sure you won't hesitate to participate actively in the Q&A, as Hannah suggested. So please join me now in welcoming our guest, Jeff Fried.
Thank you, Hadley. It's delightful to be here, and I look forward to a lot of thoughtful and hopefully difficult questions. Those are the best kinds. I just want to double check that my screen is visible and my voice is audible. Is that all true?
That's true, Jeff.
Great, great, great. So I prepared a bit of a perspective, but a lot of this will be interactive afterwards, and the focus is on the, what I would call the cognitive arms race. There's definitely a high-speed race and a set of technologies that are being adopted by all of, I'll say, the software superpowers. And I made an eye chart here that shows a spectrum of things that are in this area you would call cognitive. Despite the consortium coming up with a very thoughtful definition, I think there still is some fuzziness around the edges, but these things are all certainly agents, bots, the vision, speech, language, knowledge services, and machine learning is clearly part of the cognitive umbrella. Whether augmented reality is or not, we could talk about that. But as Hadley said in the introduction, this is a domain where there's been an explosion of services, both from the major superpowers and from startups, as well as open source. And the things that are italic here have been open sourced by these major vendors. I am most familiar with Microsoft Stack as a result of having worked at Microsoft and being a Microsoft partner. I've become much more familiar recently with the Google Stack in this area, and today that's what we're going to focus on. We'll really look at Google and Microsoft from a couple of different perspectives, but just to give you a feel for how they're approaching things, what's different, what's the same in the way they talk about things, the offering that they have in their services. I'll go through an example project that we've done on each, and DX stands for sort of developer experience. So we'll touch on that. As you can see from this chart, Microsoft and Google both cover a broad spectrum, sometimes through acquisition. Google acquired API.ai as their bot framework, and sometimes through research developments. A lot of the, both the Microsoft and Google cognitive services have research groups, very large and strong research groups behind them at their respective companies. Now, both of these companies in their battle have a lot of rhetoric, marketing, and events. They each have an event that's for the IT world in general, aimed at businesses adopting their technology. For Google, it was called Google Cloud Next, which I was able to attend in San Francisco. For Microsoft, it's called Ignite, which was in, where was it this year? Atlanta. And I'm a regular at those things. There's also developer conferences, Google I/O and Microsoft Build, which were literally back-to-back weeks. Microsoft Build was the second week of May, and Google I/O the third week of May. So these are just a sense of being right neck and neck. And in many ways, these were very similar messages, very remarkably similar services. But the character of the events also gives you a flavor of the approach of the organization and reflects their character. So, for example, the large sessions on cognitive services in the Google event were in general led by and run by people that are luminaries in the field. This is Dr. Fei-Fei Li focusing on AI. Google has been out recruiting some very well-known names in the industry, whereas in Microsoft, things are typically introduced by long-standing Microsoft execs. So conversation as a platform, which is a thing Microsoft talks about, is introduced by Satya Nadella. And then when you get into detailed sessions, you meet people that are PhDs, often luminaries, but they don't get as much front and center limelight, if you will. And another interesting thing to me is sort of the off of, the sessions that were large-scale sessions at Google I/O. This was held outdoors in an amphitheater in the Bay Area. So it really felt like a sporting event. The Build conference is very hands-on. So there's, for example, a room that has 3,000 computers separately set up with images, even in this day of the cloud, that are very effective at helping you learn and go through hands-on training. And these are quite different environments. So the maybe gives you a flavor of the events and the ecosystem around cognitive computing at these two companies. In terms of the messages, they are really remarkably similar. You hear a lot about cognitive services. You hear a lot about conversation. In Google's case, if you go to active cloud things there's a lot on YouTube, you will hear about conversations as the new UI. And if you go to anything in this area by Microsoft, you'll hear about conversations as a platform. So a little bit of a difference there, an end user or consumer bent versus a platform IT developer bent, as you might expect. And then with respect to AI, both of these companies are very actively talking about democratizing AI, making it much easier, putting machine learning into a much wider set of developers and applications. You will hear Google talk more about AI on your phone, which is obviously the Android platform, and that's the fray that Apple has most recently joined with Core ML. Microsoft has a big initiative in their trusted approach to machine learning, both in the way they approach applications as well as the way they approach sort of traditional security, privacy of information, etc. So there are some different flavors when it comes to these messages and rhetoric. Now, when you look at the real software that's available and the services that are available to you as a developer, one thing that's notable is that Google has not tried to make these a single umbrella. The API.ai, their bot framework, is still an independent thing, is not connected either in platform or in workspace, and maybe I can give you a sense of, if I look at the Google services, you'll see machine learning down here as a category that are all listed independently. There isn't sort of a top level single category, whereas with Microsoft, there's you go to a cognitive services thing, even though these services may have very different stuff under the hood. They are sort of bundled together, as Microsoft tends to like to do. Now with Google's cognitive services, they are all built on a consistent machine learning fabric called TensorFlow, which is one of the most active open source projects. So the TensorFlow is open sourced by Google. The cloud machine learning service is based on TensorFlow. All of the pre-built models in cognitive are also based on TensorFlow. The Microsoft umbrella, I've already said, by contrast, is presented as a single portfolio, but it's a sort of a bundling of things that are really separate services. I mean, Office 365 and Dynamics 365, for example, here are very big bundles in their own right. And the cognitive services within that come from a couple of different places. There's a mixture here of things like Bing Autosuggest and the web language model come from the Bing group, which has some very strong linguistic and machine learning capabilities, but they're not connected in heritage or feel with things like the computer vision service. Most of these came with a lot of involvement from Microsoft Labs, and there's still some geographically named things like Project Prague and Cusco, which have a connection often to geographies. But this is an interesting thing because you're able to play with them and work with their model. The other thing that's new recently is that pretty much all of these have a custom service, which means that you can take a pre-built model and extend it, train it yourself, rather than starting from manually building a model in the machine learning framework. I'll talk about two example projects just to give you a feel of sort of what it's like to work with these. One is something that we built recently working with a customer. It's not in production yet. I think we're not quite done, but it's really for inspection, repair, and construction to look at taking a set of images, categorizing them, and making them available along with other project notes to look for patterns, as well as to be part of the maintenance records. And this uses three things from the Google suite, if you will. The Cloud Vision API is being used to get the text out of any images, and that is actually the most dependable part. It's used to detect whether they're faces and landmarks, as well as to label images, and that, maybe to give you a flavor, let me find I'll find the Vision API. To try an image here, let me go pull up something that, this is not one of our customers' images. This is it's actually the farm I grew up on. You get a set of pre-built labels from models about concepts. Whereas if you take something out of the box, such as this is from one of our customers' example. They're looking at different kinds of transformers. The out-of-the-box model is just not very good. So this is domain specific and requires training. And then there's a custom search API. Google tends to discontinue things frequently. There was a Vision API for a Vision Search API, but this is now part of the custom search API that allows you to look for related things. And then TensorFlow obviously is the framework within which custom machine learning is built. And all of this goes into a set of project libraries so you can look for that site and what images and documentation you have with that site, both from a search and visualization of patterns, but also issue workflow. And to hook up the APIs and get these things working was quite quick. It probably took 2 of our guys under a week to get good performance on the image tagging. Is still a work in progress for us. And is definitely the long straw in this particular project. I'll give you another example, which is a sort of a support agent using the Microsoft stack connected to Microsoft Dynamics. And this is something which you can ask sort of natural language questions against and have it respond. Under the hood, this is using a number of independent services, and all of the choreography between them is custom code. So there isn't really something that says, here's a recipe that I'm going to do. Lewis is a language understanding model. That's where you put in dialogues. And you would think that very often, if you're using a speech model, you would be connecting it to a language model, which is natural, but they didn't assume that you had to do that. So each of these are really Lego building blocks. And I'll say by contrast, in this, it's not apples and oranges, but this took longer to wire up than the equivalent project in the Google cloud, in part because we're using more different building blocks. The tools for custom dialogue and custom speech and language were more sort of abstracted, easier to use for someone that isn't a machine learning expert. And that tuning is ongoing in production, but it took more like 2 weeks to wire everything up and a month to train. So that gives you a sense of 2 projects very, very quickly. Clearly, there's an arms race on now, which, in my view, has changed character a bit from building out capabilities and research and productization capabilities on core machine learning and vision to focusing on winning developers to get platform adoption or platform lock-in across. We've talked really about Google and Microsoft, but across all of these, including IBM, Amazon, Apple, and Facebook, there's to me, a palpable race on winning developers. And as a development product shop, I actively get recruiting calls from these platform vendors to say, you know, this is why you should use our cognitive capabilities. A couple of observations before we jump into Q&A. The first is, it's been remarkable to me how similar the portfolios are. There's a Vision API that does face recognition for Google. Now there's a Vision API that does face recognition for Microsoft. There's knowledge APIs in both. Machine learning is the equivalent of TensorFlow from Microsoft is called the Cognitive Toolkit. And a lot of the big frameworks are open sourced early. So, for example, you can use TensorFlow, Google's open source machine learning framework, within the Azure Machine Learning Studio of Microsoft. So I wouldn't worry as a developer as much about analyzing platforms and picking the right one up front, because I think the switching cost is not zero, but lower than it has traditionally been. The other is that all of the machine learning models are pretty opaque, and taking pre-built models, or there's also a library, for example, Microsoft has an Azure set of templates that other various partners have built models for particular domains. Working from those and really understanding what's going on and controlling it is still difficult. And it is all a matter of your training set. So if you have garbage in, you'll get garbage out. And therefore, I'd advise building in feedback into whatever application you're building and putting in some overrides that allow you to control things if and when you have to. And the last observation is that this is moving incredibly fast. Microsoft, when they introduced cognitive services 2 years ago, had 3 services. Last year it was 12. Now it's something like 38. At Google works in sort of bigger chunks, but they're rapidly putting in beta models, labs, and new services. So rather than building everything yourself, is sort of like New England weather. If you don't like it, just wait. With that, I think I can turn it over to some questions.
Yeah, hey, thanks, Jeff. That's tremendous. I know that my co-founder, Sue Feldman, has a couple of questions in mind as she's been listening to you, so I think I'd like to turn it over to her at this point to ask a couple to get us started, and then I'll turn it over to Hannah, or Hannah can take over and handle any questions that are coming in from the floor, so to speak. So, Sue, do you have a question for Jeff?
I have lots of questions for Jeff. Thanks so much for this presentation. It was great. So I guess my first one is, can you talk about the difference in underlying knowledge graphs? And there's a reason why I'm asking you about this, because bias is one, bias in data, bias in training sets, bias in assumptions of algorithms is one of our major preoccupations today at the consortium. And we're building a framework to help people understand what to look for as they select different kinds of cognitive applications. So my first question is, can you discuss the difference in the underlying knowledge graph and the data that they're based on? And how might this build in bias in the data? Do developers need to be aware of this? How can they mitigate it? And will their data be any less biased than the data that they're using in example databases?
Yeah.
To get from one of the vendors, you know.
Really good question, Sue. As I might expect from you, and a difficult one. I guess I've just finished a book called that you might like, called Weapons of Math Destruction, M-A-T-H Destruction, which really tries to talk about how biased models and lack of calibration in all of this stuff causes incredible damage in society. What I'll say is that despite a lot of rhetoric in knowledge graphs, there really isn't that much that as a developer you take advantage of. The Google Knowledge Graph is certainly biased a bit towards consumer things. If you look, this is the entities that are found in the Google Knowledge Graph. So you have a lot about music, movies, books, events, sports teams, TV series. And the reality is, as a developer focused on business to business software, which is what I do, this isn't particularly applicable. You're able to use some things about events, locations, but you're not going to, I don't feel constrained by this knowledge graph and like I'm going to get tricked into a bias I don't understand because I'm not going to really use it. You really show up with your own data, and it's more of a concern about, do you understand the models and do you understand your data, especially if you're using something that is domain-specific stuff provided by somebody else. Now, Microsoft has a knowledge API in the cognitive services, and most of it is against this academic knowledge graph. And the academic knowledge graph, the MAG, the academic graph is publications, right? Here, publications and conferences in all academic fields, because it's open source data, it's generally well curated. I actually do use this a little bit, but it's sort of alongside. Whereas if you start with the knowledge entity linking service, and you say, okay, well, this is going to give me resolution and linking linked data, linked open data, and you go under the hood, what's behind here? It's Wikipedia. And Wikipedia has some very well-known biases, but at least you know what you're working with.
That's helpful. In other words, you still need well-curated, well-understood data of your own in any case.
There's no substitute for having data and understanding your data.
And the underlying assumptions of the algorithms as well. You say this is opaque. How do you get around that?
Yeah, most, if not all, machine learning algorithms are opaque. And, you know, in some of these you have a choice of different algorithms. But I'll say this is still very hard. As you may know, I did a speech recognition startup that used machine learning that sold to Microsoft. I just left because I didn't want to work for Microsoft. Little did I know I would end up there anyway. But the debugging machine learning models is extremely difficult. Now, if you look at TensorFlow here, this is just the documentation that anybody can look at. It's clearly very programmer-oriented. The TensorFlow debugger is a command line shell that lets you look at the tensors themselves, look at the weights, understand, and therefore, for example, when do you need to change the resolution? So you need to know what you're doing for this. And there's some great material from Google I/O around machine learning where you're starting with the math. But there is a debugging facility. It's just very, very low level. To contrast, the debug facility in Azure Machine Learning, I mean, Azure Machine Learning is a toolkit that you work with, really with this drag and drop element that allows you to develop models, and you are picking, you know, different algorithms behind this. And the idea is you focus on your data, you pick up a model, a machine learning model from the library. It could be R, it could be support vector machines or SVMs, and this is aimed at people that are not machine learning experts. So they may not have a clue what SVM stands for. They can still get a model to work, but they may not understand the implicit biases and how important it is to select the right features. And the first level debugging is very easy to use. and it's against, you've got these two inputs, you've got cases where if this doesn't work, you do that. Very sort of Microsoft in flavor. So there are debugging facilities, but all of the algorithms are still quite opaque.
That's interesting. One thing I should mention in a shameless plug is that we're developing a framework for understanding what to look for as you select different kinds of cognitive application platforms or applications themselves. And my last question is simply, suppose that you were to look at the trade-off between needing answers to questions in a broad sense. In other words, let's use medicine. What are the top 3 diagnoses I would recommend for this patient? Versus the serendipity involved in, I don't know what to ask. I have a massive data here. And what I'm looking for is patterns that I don't know enough to ask about. I'm looking for discovering the unknown. I know the known. What can you tell me I don't know and don't know enough to ask? So which one of these would work better for that? And I'm sorry, this is out of left field for you.
Yeah, it's all out of left field for me. So I guess to put it into the jargon of the field, one of them is classically called a question answering system.
Yep.
And the other is classically called knowledge discovery. They're both extremely active in academic research still, as well as having different a lot of different commercial offerings. And I'll say to first order, I still think that these frameworks are developing. It's still early, and they have enough power to do either. It's sort of like all computer languages are Turing machine complete. You can get the job done in either of these platforms. I think the Microsoft framework is easier for dialogue design because you're provided things at a more guided level of abstraction. They make it really easy to pull in pre-built dialogue elements around weather, et cetera, et cetera. So, they now have, as of about a month ago, the sort of custom dialogue studio. So I think it's easier to get a question answering system up and running and understood. Whereas I think that, I'd guess that working directly in something like TensorFlow with the various connections to things would be easier to do in the Google fabric. But I think they're not that different. I mean, API.ai, which I personally haven't used very much, has dialogue design tools, and Microsoft has the Cognitive Toolkit or TensorFlow, and R can be hooked to that. Lots of visualization. So I hope that answers your question. I would guess that Microsoft's stack would probably be better for the question answering system, and Google's would probably be better for the knowledge discovery. But some of this is a matter of preference, ease of use, and there's not a lot of lock-in in the platform, but there's a lot of convenience to using the same platform for all of your services.
Thanks.
Thank
This
you.
is tremendously useful. Over to you, Hannah.
Thanks, Sue. We do have one question from David Blackman, which is, should we be concerned about IP when we import models into these various platforms?
Another great question, David. I don't know. For sure, the pre-built models. So let me just talk about the Microsoft example. There's the cognitive services APIs have clear. It's very clear that you are not. using them doesn't have any copy left. You can use them and not be worried about your IP. Same thing with Fabric. The stuff that are pre-built experiments published in the Azure Gallery, they all have their own licensing terms in the fine print. And I personally have not used any of them yet. Whereas, things that you build in these studios are obviously your own IP.
Great. Well, if there are no other questions, that concludes our program for today. I'd like to thank Jeff again for taking the time with us, and the recording of the webinar will be available on our website most likely by the end of the day today. And we hope you can join us for next month's webinar. Thanks, everyone.